Hello everyone, in this video we are going to use a sample data set to start using pandas while we are manipulating a data but also learn about its different features and the way pandas can be helping us. So the data set we're going to be working with is the dataset adult.csv that is going to be provided the link to you for you to be able to download it and be able to start using. So adult data, basically adult data is the consensus data set that was collected in 1996 and it has 48,842 instances. One thing you need to pay attention here with this data is the fact that this data is not, every row is not one individual. Every row is a representation of different individuals. And this for the population of the US in 1996. And there are like 14 attributes. One of those attributes shows that what is the weight of what are the numbers of people in the general population that this row represent, which we'll get to see. So the first thing you need to do is to import pandas, because that's what we're going to do today in this video. So once we import pandas, now we can say pd.read.csv adult.csv. So for this line of code to be working, you would have to have the adult.csv file in the same folder as the folder you're keeping your Jupyter Notebook file, which here we have pandas example data. So since in my computer I do have them under the same folder, adult.csv file, and also the pandas, the Jupyter Notebook file. That's why once I run this code, I would be able to open the data using the module. So make sure to have these two files in the same folder in your computer before you start running this part of the code. So once you run this code, you will see that you have, so many rows, and you can see that Jupyter Notebook breaks the code from line 30 and then also only shows the last 31. So it only shows you the first 30 and the last 30 datas. These preferences of Jupyter Notebook could be changed. It could be showing all of the data, or it could be showing just like the first or second rows of the data. But it's here showing all of the columns. As we saw, there are like 14 columns. So we have age, work class, final weight, which is basically, as I said in the beginning of this video, is the number of people that this row of data represent in the general population. And then we have education numbers of years. So these two columns are connected. So if if your education is bachelor, you have spent 13 years doing your higher education. And then we have during your whole education. We have marital status, we have occupation, relationship, race, sex, capital gain, capital loss during that year, hours per week of work, and also originally where those people are from, and then how much is their income. Is it smaller than 50K or greater than the 50K? So that's basically this data set. So let's start using some cool features with pandas. One of the things that could be very handy, especially when just looking at the data and wanting to see the structure, is df.head. And basically when you say df.head, instead of showing you all of the data and sort of grabbing this much from your screen, it just only shows the first 5 rows in your data, which is very useful. You could change how many rows, the first rows you want to see. So if you say df.head 8, it will show you the first 8. If you were to say df.head 2, it will only show you the first 2. The same thing with df.tail, it will show you the tail of the data, or like the last few rows. And you could also say how many numbers of the last few rows you want to see. As I said, you could change the preference for how many maximum column and maximum rows that you want Jupyter Notebook to show. So if I change the maximum rows to 15 and the maximum columns to 10, so we will see that once I call the df, now I'm only seeing 7 from the top and 7 from the bottom. And so like there are like 15 rows I'm seeing, and also only 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's important sometimes once you're like, relying on these outputs, so you could be setting your options, seeing how many you want the pandas to show for you. So let's look at a couple of ways you could like be filtering data. Very useful way of filtering data with pandas, as we learned during NumPy, was Boolean masking. So let's take a look at a couple of examples here. So we want to only keep the data of people whose age is older than 40. So simply we can create a Boolean mask by just keeping one series and saying that series is greater than greater than 40 or not, and then it will create a mirror series that is filled with true or false. So once I run this, now I have false or true. Now I can use this Boolean mask to filter my data frame. So now all of the data that I'm seeing here, they're only the rows that have age greater than 40. And as you can see, some of these indexes are not like from 0 to 0, 1, 2, 3. So like, you can see some jumps here, and that's because this is not the whole data. You're just like filtering it out based on the Boolean mask. Another example, let's show all of the people who have masters and their income is less than 50K. So that's a new condition. So we create a Boolean mask, first Boolean mask that education is bachelor. Actually, we want masters. So we have to change this to masters. And their income is smaller than 50K. So we create the first Boolean mask, the second Boolean mask, and we use the condition AND to make sure both of these are happening in my general Boolean mask. So once I run this, now I can check that all of the educations are masters, but also the incomes are smaller than 50K. So simply I was able to sort through just keep the part of the data that I need to work with. So the next thing that we will learn how Pandas can help us is basically sorting. You could do both the sort index or arg sort as we did in NumPy, or by sort values. So by sort values, you're basically saying I want to sort the whole data frame by the value age. So one thing you need to pay attention here is the fact that the function sort value does not sort the data frame, but it only spits out a sorted data frame. So once I run this, now I have a sorted data frame for sure. Like, the age start from 17 all the way to 90, but my data frame is intact. It hasn't changed. It has its own, its original structure. So it's not going to change your data frame. It's just going to sort and spit out a what you want to see, what you wanted to sort. So here, to sort of keep that, I'm keeping that as a sorted df. So to have that df that is sorted for me. So that's the trick that I'm using here. You could also, contrary to NumPy, you could say if you wanted ascending or descending. So if the default is ascending, if you wanted descending, you say ascending false, and it would reverse the sorting for you. And you could also flip back sorted data that you kept for any reason by saying sort by index. Since the indexes are from 0 all the way to n-1, and it will like revert your data back to its original form. A lot of times, one of the things that we need to figure out is where are the null values, where are the missing values in a data frame. And that is important because we will see in examples, sometimes our functions are not going to be working because there are like non-values here, like non-values there. So let's see if there are any non-values for the native country. So once I run this, now I can see there are a lot of values in my data that their native country is NaN, or missing value. And the way we went about this was we created a Boolean mask by the function is none. So you can see that we are not using our customary way of creating Boolean mask. We're using the function is none, and which basically spits out a Boolean mask. And we're using that Boolean mask to filter our data. Pandas also have a lot of powerful functions to work with strings. So here we see a couple of examples of them. So for example, you can see all of the countries, or all of the native countries of these rows that start with I. So we want to see the data that their countries only start with I. You can simply say I want access to the string functionalities in Pandas, and then say start with, which is like a function, and you just pass that letter to it, and it will work for you. But we will see an error here, and before moving on to watch the rest of the video, stop here and have a moment to yourself to think about why we are seeing this error. So the reason we are seeing this error is actually being reported here. There are like NaN values. So for us to be able to run this, now first we need to take care of our NaN values. So as we saw, we could filter all of them out by Boolean mask. So why not we create a second data frame that only has the ones that the Boolean mask are showing false. So by using tilde here, I am reversing the whole Boolean mask. So wherever it's false, I want true. And then I'll get my second data frame that has all of the, that is ensured that all of the native countries are in fact filled. There is a country there. So now I can say df2 native country start with I, and that is just going to work fine for us. And we can see that all of the countries that start with I are listed here. You could also have done this very similar thing with ends with and contains. Ends with is gonna show you the strings that ends with a letter or ends with a collection of letter, or contains is going to show you the columns that contain a specific value. So for example, for the work class, let's filter out all of the work class that contains the word government, or like gov. So we can say df str contains gov, and then it gives us a similar error, because so we need to figure that out first too. So we filter out all of the ones that are null based on the work class, and now we use the df2 to create that Boolean mask, and then we use that Boolean mask to filter out, and we can see all of the data that has the section GOV inside the work class. And lastly, a couple of very good functions that we could be using to do some calculations with Python. One of the useful function is value counts. The value counts gives you an output that tells you the unique values that a series have and how many times they have occurred for you. So for example, I want to know how many from each, how many rows there are in this data that has different countries. So I can say value counts on the series of the native countries, and it will show me all of the countries and how many times there is a row that has repeated with that value. So we can see, of course, United States comes first, and so on and so forth, the rest of the possible countries that were in the consensus in 1996. Here I have changed the max row because I wanted for us to be able to see all of the possible countries here. We could have done, if we just were interested to know the countries that were in the data, but we were not interested to know about their frequency, we could have used this function. We could have used the function unique. So if I copy this and say unique, now we're going to get an array that only shows us the countries that are in there, so the unique countries. So the list here that we have is going to be the same list as we have here. There's another example here. We want to see how many types of work class we have. You can see we have state government, self-employment, private, federal government, local government, NAN, which is missing value, self-employment, without pay, never worked, and these are the different types of work class that exist. Then we can do all sorts of calculations, summation, the average, maximum, minimum, variance, mode, median. All of those are possible. So for example, if you say df.median, all of the columns that are the numeric type are going to be calculated, their median, and they're going to be shown here. So let's look at another one. Let's look at the mean. So it's going to calculate all of the mean for all of the numerical columns in your data. If I just wanted one of them, I could just specify what I want. So for example, here I have hours per week. I'm just interested to know about the mean for this one. And once I run this, now it's only going to focus on that one, and it's going to give me the same result. I've got a couple of other examples here as commented. Once we have a comment in a line of code in Python, which I'm pretty sure you know, it's going to just skip that part. So it's skipping all of those parts because they're commented out. It's just going to run this one. So I've kept them here for you to just see there are other possible examples you could be doing. And lastly, the function describe is a very useful function when you just want to take a quick look at the data frame and see what are its many different aspects that are happening. So if you say df.describe, it will show you the count, mean, standard deviation, min, 25%, 50%, 75%, and maximum, all of your numerical attributes. You could specify specific column, and not run it for all of them, but it's also going to be working just fine if you did that too. Like I said, describe is a very useful function when you just have just the data. You just want to like look at it, like see some of the statistics that can help you have a better sense about the data.